Alright, so this is the video that I owe the lab report Anon from a couple days ago. I now have my webcam, my monitor, and I've got my graph paper, yay! Which means I can actually show you how to do this rather than hand drawing graphs, which turns out to be multi-size squares and not very helpful for you, unfortunately. So, I just saw your message. Yay, video's on the way. So here is my recommendation. You'll need some graph paper, pencil, and a calculator. So for the first, I went ahead and drew the first circle in my last failed video because I just failed to make a video. So I used the 4, which is what I used last time. And I got roughly 9 squares because I had 4 whole squares, 4 squares that were about 75% full, and 4 squares that were about half full. So 4 plus 3 plus 2 is 9. So then what you'll want to do is take that formula I gave you, which was A equals pi times diameter over 2 squared. So in that case, plugging in your diameter, which is 4, you'll have A equals 4 pi, assuming pi to be 3.4, or 3.14, sorry. Assuming pi to be 3.14, you'll get 4 times 3.14, which equals 12.56. So that doesn't exactly correlate, but in the scheme of things, that's not terribly awful. It also depends on how well you draw your circles and guesstimate. The next circle, for the purpose of having something easy, let's pick 6. So I'm going to draw diameter circle thingy with 6. Not 7, which is what I just drew. So sometimes this does not work. And some of my circles are very poorly drawn. So like I said, it kind of depends on how well you draw your circles and what you estimate. So this time I've got 1, 2, 3, 4. I've got 16 whole squares for sure. This is for a diameter of 6. The last one was a diameter of 4. In a second I'll probably do a diameter of 10 because that's easy too. We've got 16 squares inside there, whole squares. So partial squares, I've got 1, 2, 3, 4, 5, 6, 7, 8 that are pretty much 3/4. So 8 times 3/4 is about 6 squares, roughly. And next I've got about 1, 2, 3, 4, 5, 8 half squares, so that's 4. So 16 plus 6 plus 4 is 26, roughly. Your averages probably really won't be whole numbers on account of the fact that you actually probably will estimate them very well, and I'm just roughly estimating them to keep this a sort of short video-ish, because apparently there's a 5-minute video posting limit, but if I go over it, I'll just send you a link to YouTube. Sounds legit. So using the diameter of 6, we'll use that formula again, which was, well, pi diameter over 2 squared. So, just so I can show you what I've been doing instead of just talking to you, I've been drawing the circles. There's 4, here's the 6. Now I've got the formula written out to the side there, so I'm going to solve that real quick. So now we've got 3 pi squared, so 9 pi, 9 times 3.14 is about 2826. So as you can see, that's a little bit closer than last time. And one of the things is the bigger diameter you use, the more accurate your calculation will be with the estimate of counting the squares. When you have smaller numbers, you have more room for error. So there's a larger margin of error, and so with the larger squares, or the larger diameters, you can eliminate some of that margin of error. So for the last one, start a new page here. I'm going to go ahead and do a 10. Drawing circles is fun and it's entertaining, but I'm not very good at it, so it's really not that helpful. Yeah. So this is me drawing circles because I'm awesome and I'm really special, and I make videos now because I'm cool. I was always going to make like web videos, but now I'm really cool and I make homework instructional videos instead. I'm totally awesome and I'm singing while I'm making this video, so I'll probably edit that out. And so it doesn't really matter if I can figure out how to edit it. It's gonna be gone. Gone, 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 gone. Okay. That's my poorly drawn circle for 10. Okay. So diameter of 10. Counting these squares inside. Let's see. 1, 2, 3, 4, 5, 6. 36 plus 24 is 60. I'm gonna make that 68. Okay, so then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so I've got like 12 that are 75%. So 75% of 12 is 9. 68 and 9. And let's see, I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 half squares, which is 4. And then I've got 1, 2, 3, 4 squares that are like 10% each. So we'll say 0.4. So 68 plus 4 plus 9 is 68 plus 13 is 81. So that should be about 81.4 squares. In this case, it's going to be 25 pi after you go through that whole little jazz thing. 25 times 3.14 is about 78.5. So in this case, my circle was actually bigger than it needed to be. So after you do that, what you're going to do that for as many squares as you want, whatever diameters you want. Then you're going to make a graph. I guess you could do a bar graph, really. If you do a bar graph, what you'll want to do is on the bottom, you'll want to put what your diameter was. And then if you do a bar graph on the y-axis, you'll just basically put your values and calculated values. Just make sure you tell which one is which. So for a diameter of 4, I think we had 9 and 12.56. So I colored in the estimated and did not color in the calculated. That's what I'm graphing right now, just so you know. The bar graph. I like bar graphs. Bar graphs are cool. For 6, we had 26 and 28.26. So there's 6. And I'm not going to do 10 right now because David Tennant's not here. Just kidding. But I'm also not going to do the 10 because I didn't really leave myself enough room. But kind of the same idea, you know, just pick what you want to do and plot it and show a graph of the correlation. The more diameters you choose, the more work you'll have to do. No. Well, yes, but the more accurate your results will be, like the more values you choose, just because there's less room for error. So I hope this helps. I'm in my new chair, which is awesome. And thanks for popping by my Ask box, and please let me know if I can continue to help you. And I really hope this helps. So I'm going to edit this now. Bye!